Okay, so morning everybody. Today's class is going to be about memory. Till now we have seen combinational circuits and also sequential circuits. Today this is a new topic which I am going to introduce is about memory devices. Okay, so there are several types of memory devices which is used in digital systems. RAM. Okay, so many of you might have already heard this term RAM. Okay, so this is generally whenever we speak about laptops or desktops, whenever we are trying to buy a new item, so RAM becomes a major consideration. Can anybody say what is RAM? From whatever little you might have heard about it, can you switch on the mic and say? Anybody? Now, why is the RAM required? Anybody?
So like the instant processing memory, like launching of apps, like the
Yeah. Yeah. See, the major part of you, no, whatever data or operating system and all, they are all stored in the hard disk. Okay, so not all of the data which is there in the hard disk is used at a time when when you're operating, when you have opened up your laptop or desktop, you're running some programs. Not all that data is required, right? Only few data is required. Some specific data of the hardware is used. Okay, once you are doing say some particular application, so only so if you don't have a RAM, okay, this what will the CPU will do is it will keep going and asking the hard disk for data. So the read and write operations will be very sluggish. So RAM is kind of an intermediate storage space where the program which you are currently running, that is fetched from the hard disk and it is stored in the RAM, and now the memory, the CPU will read and write the data from the RAM or from the RAM itself. Okay, so the RAM is pretty fast, so it can operate at a much faster rate than the hard disk, so that is why. Okay, so there are some other peculiarities of RAM. Can anybody say what are the some other? You can just try and say from whatever little you know about the system.
It's a temporary volatile storage. I mean, it is erased once it's powered off.
Yeah, correct. So it is erased when it is powered off. Okay, so you have a RAM can perform both read and write operations. Stored information is lost when power is turned off. Okay, now the other kind of memory which we have is a ROM. Okay, that is read only memory. Okay, so this is also a part of the your CPU in the motherboard itself. You will have ROMs. Okay, so there the data is written into the memory by the manufacturer. Okay, so you don't have any access to that. So it will have some boot sequence and some for the CPU to initialize. Okay, so those data it will fetch from there. Okay, the sequence of operating once you power on the system. So and also the ROM will have some triggers from high temperature. Okay, what actions it has to take in case of a low battery signal which is coming from your laptop, or when there is a high temperature which is sensed. Okay, so some kind of information which you don't no, it is not related with the user but with the functioning of the board itself. Okay, they are pre-programmed by the manufacturer. You don't have any control. Okay, all you okay, so all of you are able to hear, right?
yes, sir.
Okay. So so they can do the read operations. Suitable information and can be retrieved. It is the most and it's pretty fastest. This is the fastest, then the RAM, and then the hardware. Okay, ROM is the fastest. It is because it is just the read operation, so it will be the fastest one. Okay, and then you have something known as a hard disk that we all know. Okay, it can read, write, and it is non-volatile. Okay, so the data will be stored permanently. So till now we had a magnetic type of hard disk, most of them. Now we have SSD, that is solid state devices also. Okay, while the solid state devices, as compared to the magnetic disk, they can operate in a pretty at a fast rate. Also they are more reliable. Okay, magnetic, more or less, if the magnetic disk, there is a problem with the magnetic disk, the data entirely is lost. Okay, there are many mechanical elements which are, if you see the hard disk, the disk rotates and there is a head and all. So if something goes wrong, and it rotates at a pretty fast RPM, more than 1000 RPM. So if something goes wrong with these magnetic hard disk based hard drives, then the entire data is lost. SSD is more reliable. There is nothing mechanical which is rotating. You are able to access various registers through switching of the transistors. So this is going to be and it is going to be faster also. So slowly maybe 5 years, 10 years down the line, you will find it magnetic hard disk is not available in the market at all. So SSD will replace all the magnetic hard disk hard drives. Okay, so now what is this? So now first we will tackle about read only memory. Okay, so read only ROM, which is known as ROM also. Okay, the ROM could be, and so to begin with, let's distinguish what is a byte and a word. Okay, an 8-bit data is called a byte and 16-bit is called a word. Okay, so most of the processors, initially it was 8-bit, and then we graduated to 16-bit processors, and then now we have even 32-bit processors. Okay, so they are known as the double word. Okay, 32. So these are 16-bit is called a word. Okay, now the block diagram of an RAM is shown here. So you have an input address. Okay, once the input address is given, so it will decode it, and one of the line, it will select one of the lines. So how many lines will be there? 2 to the power of n lines will be there. Okay, so one of the lines will be selected. It will be clear in the next slide. And then each line will have one data available. So if it is an 8-bit ROM, then the number of individual memory cells will be 2 to the power of k into n, where k denotes the input address line. If it is an 16-bit output ROM, okay, then it will have 2 to the power of k into 16. So that is how we represent this as 2 to the power of k into n, the ROM. Okay, so let's see how the ROM functions. Excuse me. So ROMs, see in the ROMs, before we see the architecture of the ROM, okay, there are millions of gates connected, and there are so many internal parts. So just to simplify the representation, okay, we will if this is the AND gate, 4 input OR gate, we are going to represent it like this. Okay, okay, it means the same, only the representation is like that. It's an array logic only. Okay, we'll use this symbol for an OR gate instead of this. So so that becomes easy for understanding. It will not be clumsy, that's all. Okay, it means the same only, just to make it look simple. Otherwise, once we have lot of vertical lines coming in, and we will use cross, like there will be so many vertical lines running like this. So wherever there is a interconnection is available, we'll put a cross in those junctions. Okay, if I put a cross here and a cross here and leave the crosses here, it will denote an A or B. Similarly, if I put a cross here and I leave the cross here, it will denote a C cross D. So this is the notation which we are going to use in the next few slides. Okay, so read only memory. So now if you see, it is got an decoder and it has got an output. Okay, so there are, so whenever we want to address some line, okay, we want to fetch the data from some address line, we will place that address here, right? This is a 5-bit address line. So 5-bit address line means you will have 32 unique outputs available, and they are of, in this case, they are 8 different lines are available, right? So 8-bit data is available. So if I give 000 as an input, this particular line will be enabled. This will go high. So what is the data which I require here, what I want to store here? Okay, so I'll make crosses here, I'll make the connections out here. So So if I have to address say some other line, say 28th line address, what is the data which I need? I am going to read this data 0 to A7. So there I am going to put yeah, I had some internet issues. Are you able to hear me now? Yeah, okay, okay. So tell me, is this operation of RAM clear? Anybody has got a doubt? Please switch on your mic, then we can discuss it once more.
Sir, can you repeat this circuit?
Yeah, okay. So this is an decoder circuit, right? So this is a decoder circuit. We are going to give say 0 0 0 0 all the input. So what happens? This line will go high. Okay, the topmost line 0 corresponding to the minterm 0 0 0 will go high, right? So this is the output data A0 to A7. It's an 8-bit output data, right? So now what is the, suppose I want say 1 1 0 0 0 0 to be stored in this particular ROM at therefore this 0 0. So what I do is I will put a cross here, I'll put a cross here. That means I'll make a connection between these two lines. I'll make a connection between these two lines and leave the connections out here. Then I will get an output of 1 1 0 0 0 0 0 here. In the next okay, so it's a 5 line, so I can have 32 unique values stored in this particular ROM. So suppose I give 0 1, right, I am giving a minterm equivalent to 1. Okay, that is 0 0 0 0 0 1 0. So that means this line will get activated. Once this line is activated, okay, now suppose I want to store a data, okay, 1 0 0 0 0 0 1. So I will put a cross out here. I'll make a connection here and I will make a connection here and I will not make a connections here. So this will become 1 and this will become 1, rest of them will be 0. How these connections are made, that we will discuss now. As of now, is the understanding, have you understand how this memory is programmed and how it works? Anybody has got any doubt? If it's not understanding, tell me. Okay, right? Okay, so we'll move forward. So now we have to understand, okay, how it's not visible, this.
So like black background and
Okay,
pointer is also.
no point, no problem. I think my morning tutorial it was white background devices. So is it visible now? Or should I increase the size of the still further?
The state's black only. Now it changed.
No, it's there. I'll increase the size also so that it becomes. Yeah. Okay. So so this is how the mode. Now we got to understand how to make these connections. Okay. So this is an a 5 to 32 decoder. Okay, you have, this is pretty straightforward. Okay, now if you see what is, these are the connections which has been shown here. For example, if I give into the address, okay, in the address corresponding to 3, if I give like 0 0 0 and 1 1 here, I1 and I0, I give 1 1 here. So the output will be, this line will go high. So the what will be the output? Okay, there is a cross here, there is a cross here, there is a cross here, there is a cross here. So to wherever there are cross, it will be 1, and wherever there is no cross, it will be 0. So you will get this particular data. Okay, so these crosses are going to be placed permanently by using a fuse link or something like that. We will see what are the different ways of making these crosses, making these physical connections between these wire and this wire. Okay, they will be permanently by the manufacturer, these lines, wherever there is a cross, these two lines will be shorted to each other. Okay, so you will get the whatever data is required. Is this much clear to all of you? Anybody
Yes,
has
sir.
got it? Okay, okay. So now we move forward from here. Right now, how to make the connections? Okay, so this is how an VLSI IC looks like. Okay, so this is the base. Okay, it is known as the bulk. Okay, and then you make different devices. Okay, so there will be millions of devices, and between these devices you have metallization. Okay, this metal is going to connect to here, right, to this device, and then to make it compact, right? If you have a single metal layer, when you make millions of connections, okay, they will not be able to, you will waste lot of silicon area. So you have multi metal layers. Okay, there will be lot of metal layers. So if you, and between the metal layers, okay, there will be an insulation. So you will be able to run different metals, one over the other, and wherever you need to connect between two metals, you will make a small hole, a via, and connect it here. Okay, so these are just, I am giving you an what a rough idea about these things. You don't have to remember all these things. Just there is a bulk, there are various devices, and there will be metallization. So the initial the first kind of ROMs which we were made, so they used, like when these metal lines are being run, it is used, a mask is used. Okay, you put a mask, and through that mask, wherever required, only there the metal lines are pasted. Okay, so similarly, so those kind of masks were used even to make the ROM also. So wherever required, some mask is, okay, initially there is only a device, then you put a mask. In those masks there will be some cuts through which the metal can be deposited. So wherever there is cuts, the metal, okay, there the these things are wherever there are cuts, there the metals will be deposited. So that's how it is being used. Okay, is it clear? Is still mouse has become an issue? Okay, because it's a white figure, I guess. Okay, let me do something. Okay, so so let me just rewind it a little bit. So what we are going to do is, we are giving an input data here, so the corresponding lines will go high, right? So once we want the data which is to be read from here, so we can program. So for example, for line number 3, if you want a data to be stored 10110, this is the data which we require to be stored in the memory location 3, then we are going to put these crosses here. Okay, so then this particular data, whatever is available in the output, would read this data. These crosses indicate that there is a physical connection which has been made between this vertical line and the horizontal line. These crosses just indicate that these two lines have been interconnected at these junctions. Okay, now so we will now see how these junctions are made, how these interconnections are made. Okay, so the first option which is available to is through masking. Okay, so like I said, this is an base, which is a which is an bulk, which is known as a bulk. These are the various devices which are being placed on this bulk, on these bulk devices. Now what we are going to have is, like in a VLSI chip, there will be numerous millions of transistors which are placed on the bulk, and now we need to do the interconnections. So if we use a single metal for interconnection of all these bulk areas, then we will, it will require a lot of space, because you can't run lines very close to each other, they have to space. So all those issues will be there, and then although the metallization, the routing itself might take more space than the chip itself. So to overcome that problem, what we generally have in VLSI is multi-layer metallization. So they will have multi layers. Each of these metal layers are separated by an insulator. So two metal layers can run over each other, okay, without being shorted to each other, because there is an insulator. So that and then you can have, wherever there is a requirement of shorting these two layers, you can use an via. Via is a small hole which is drilled, and metal, you pass metal through and through. So they get connected to each other. So because of which what happens is your routing becomes easy and it will become compact. Okay, so for ROM what we do is, so we are going to for the ROM we are going to tell the manufacturer while fabricating wherever we need connections, okay, between two devices, okay, we will use these kind of wires. Okay, you connect these two wires. Okay, say all the these lines are metal 1 and these are metal 2. Suppose these are all metal 2, these are all metal 1s. So we run those lines, and wherever there is a requirement you can put a wire. Okay, so now, so that's why during manufacturing, so you will see the mask will look something like this. So there will be some connections which will be made between these two wires. So this is how we realize it. Okay, the problem here is, okay, once it is programmed by the manufacturer at the field level, you can't do anything about it. Okay, it is during the fabrication process it is programmed, and that ROM becomes an purely PROM becomes it is programmable. Then once it is programmed, it becomes a pure ROM where you can only read from the memory. Nothing can be done about that chip. Okay, that chip cannot be programmed with anything else once it is fabricated. Okay, only programming is possible prior to fabrication. In between the fabrication process, during metallization process only we can program it. After the metallization is done, it ceases to be a PROM. It will become only a pure ROM. Okay, so now again the second kind of PROMs, the ROMs where you can do these interconnections is by using a fuse technology. In the fuse technology you have, see, one layer of metal running. This is the second layer. So while for fabrication we are going to put an vias all, a very thin via is interconnection lines. Okay, very thin lines here. So after doing that, once the chip is fabricated, then you program it subsequently. Once the chip is fabricated, you are going to programming after the chip fabrication. So wherever we don't want, okay, these are known as the fuses. Wherever we don't want the connection, we are going to blow them off by giving an extra supply voltage. Suppose this chip has been fabricated for 5 volt operation. Probably by giving 12 volt, that will be specified by the lab itself. Okay, what is the voltage you need to give to fuse the links? Okay, so these links will be fused out by giving an extra voltage. So these links will get blown off. So then you realize the ROM which you require. Okay, so this is the second method of programming an ROM. Okay, again, once for all ROMs, once it is programmed, you can't do anything about it. Okay, in this also, once it is programmed, now there is no way you can make this link, bring this link back. Okay, because it is blown off, it is gone. Then it will become a ROM, right? It will become a ROM. But if you see here, it is not related with power supply. Even if there is no power supply, and it would still work, right? It is not power supply dependent. Okay, that is the great advantage. And also it is pretty fast. If you see, all these connections are hardwired. Okay, so it will operate extremely fast than any other ROM or hard disk. Okay, but the only and it doesn't require power supply. The only problem is it is not programmable. Once it can be programmed only once. Okay, so that is okay. This is again a schematic of from the fab lab, how you can see various fuses here. This is the first stage where all interconnections are available, fuses are available. So in this diagram, and then subsequently we are going to blow off whatever is not required. Okay, so that comes. Okay, the third kind of raw fusible links, whatever you call it, is EEPROM. It is electrically programmable. Okay, what is electrically programmable is, right, you have a ROM out here. It uses a floating gate technology. Okay, so you don't have to mug up these things, and these are not going to be asked in the exam for design or something. Okay, because it involves some kind of some superficial questions will be asked, but not in depth. Okay, because you need to know the device physics to understand it properly. So I am just giving you the basics. Okay, there is something known as a floating gate. Okay, what does the floating gate do is, whenever you want to program this gate, okay, you give a voltage. If you give a voltage here, what happens is some ions get trapped. When you give high voltage, some ions get trapped into the floating gate. Okay, once they get trapped, when you give a high voltage, some ions get trapped here. Okay, those ions will make an conduction path between the source and the drain of this transistor. So this becomes a kind of short circuit. Okay, so this is known as electrically programmable ROM. Okay, so you can do it electrically, you can program it. Okay, now the advantage of this is you can erase the data by passing ultraviolet rays. So for these PROMs, you will find there is a glass placed here. This is an ROM IC. There is a glass placed here. When you put an, see, the ROM is only this much here. Okay, but you want the pins out. So that is why all these interconnections have been brought out on both sides. So the actual ROM is just this much. So once you expose this to ultraviolet rays, then the data gets erased. So whatever is the trapped ion, okay, they go back. Okay, so again you can reprogram it. Okay, sorry, you can again reprogram it by giving the voltage here. So these kind of ROMs can be used for n number of cycles. Okay, is it clear till here, all of you? Anybody has got a doubt? Okay, so these are you can program it. Okay, now by using you can write the data giving electrical pulses, and you can erase the data by giving UV rays onto this. Okay, so if you open up a few laptops and all or desktops, you will find these kind of ICs. If there is a glass kind of these things, you can easily make out that is the ROM. Okay, so even that is gone now. Presently what is the technology is double EEPROM. Okay, what it means is it is also has got some floating gates available here. So whenever we given a voltage and a high voltage, some charges will be trapped in the floating gate. Okay, so it will store a 1, so that a connection will be made, and whenever we want to reset it, we give a 0 volt here and apply source and voltage here, so it will erase the data. Okay, so by giving 2 types of voltage on the gate, we can permanently store a 1 or a 0 in the floating gate. Okay, so here you can electrically erase it and electrically program it also. So this is the another kind of ROM. Okay, so have you understood how various ROMs are there? You just have to superficially know, okay, these are the various kind of ROMs and all, because these things involve physics. Okay, how the electrons get trapped here and all. So that is out of scope for digital design course. I am just giving you broad. Okay, in an interview, if you are asked to differentiate the operation between these ROMs, you should be able to answer something about it. Okay, even the computer science students. Okay, these are the basic differences between the various kind of ROMs. Okay, is it okay with all of you? Shall I move forward now? Can somebody say something? Is it clear till here? Am I audible? Okay, okay. So let me move forward now. Now these are the kind of questions which you can expect in your exam. So here I said we can also use the RAM to design some functions. Okay, some permanent functions, logical functions. Okay, so if I give A0, there are 3 functions here given, F0, F1 and F2, and we are saying okay, only 3 address lines we are using. These are known as the address lines. Okay, only 3 address lines we are going to use it. So we know A0, A0, so we write these functions F0, F0, F2, F1 and F0. We are going to write it in all the 3. Yes, I'll come back to EEPROM once I finish this slide. Okay, so these are the 3 functions which we have written here. Okay, so now when we activate these minterms, one of these lines will go. So how to take out the functions? By programming the particular lines, the PROM, by using one of the techniques which we discussed earlier, by making the connections at the required place. Okay, so this is going to be the data which we need to make. Okay, so 0 1 1 for minterm 0, 0 1 1, 0 1 1 indicates that it is 0 1 1, cross is here. So using this data we are going to program the ROM, right? Okay, so this 0 1 1 1 1. This is the sequence. That means in each of these lines there will be no connection made here, connection made here. 0 1 1 indicates that. Okay, here it is 1 1 0. So it means that for this particular line the connections will be made here and here. So this is known as the ROM table. Okay, this is known as the ROM table. This table will be given to the fab lab or to the programming tool which is going to program the ROM. If you are doing it in your lab, then you have this ROM table will be fed to the software. Accordingly, it will make these connections. Okay, it is not this ROM table is like you don't have to really tell the it is mapping here directly here, but not necessarily. So it is not bothered about the software is not bothered about this function what you are going to implement. Okay, the software which is going to program the ROM, you just have to tell about, okay, what is the connections which is required to be made. It is only bothered about that table. So you need to generate this table and give it to the software, so it will make the connections accordingly. So you will get different functions. So this is okay. So we will see in the next example that your function could be different and your ROM table will be slightly different. That we will see. Okay, so yeah, is it okay? Okay, how to design an ROM table, all of you?
Sir, can you explain how do we read that ROM table once again?
See, this table, this indicates in the first row. It is 0 here. Connections is to be made here. So wherever
Sir, values in the the parenthesis values, sir, what do they represent?
that is it. You write if this is 0 1 1 is 3, right? 3.
Okay, the
the numerical value. So you need to feed that in your programming in your programming language where it means that. Okay, so here Sai, what we are doing is there is an whenever we want to program this to operate at the one, we give a high voltage to the gate. So some ions will get trapped in this in the floating gate. So once they get trapped here, they will make a channel, interconnecting channel between source. So it will store a connection cross. It will store a cross. Cross means they're interconnected. Okay. So you give, say, like you give 20 volt here, it will get. If you give again, if you want to erase it, you will give a 0 volt here and then you apply 0 and 20 volts. So whatever charge is here stored, that will get dissipated. It will go back to the into the bulk. Okay. So then this will store a 0. So you are using two different voltages to program it and erase it. There is no ultraviolet required. Is it okay? Ultraviolet trace is not required. These are all programmable.
So like are they reprogrammable? Like,
yeah, they are reprogrammable, right? Both this one and this one, both are reprogrammable. You can repeat.
okay.
Both you can do that. Okay. So this is how you design an PROM. So ROM can be used, okay, to save several data, say in 8-bit or 16-bit data, okay, for given input address lines. That is one application. The second application is sometimes, okay, you want to program it for a fixed function. So these functions can be permanently programmed here like this. Okay, this also can be done here. For example, if you are going to make some circuit for an industry where you have n kind of inputs coming in here, okay, from the AC, from the temperature, from the pressure, and maybe the chemical composition and all, there the functions are going to be fixed. Okay, if these functions are going to come, this will be the output. So it is not going to change over a period of time, or daily you don't have to change. So in those cases, instead of realizing it with NAND NOR gates where you program it and you give the power supply, okay, every time, and if there is a power supply failure, again you need to programming, okay, or you use a PCB and hardwire it and n number of NOR gates and NAND gates. Okay, instead of that, you can do it along with an memory device also, like this, with a EEPROM also, so that those data are permanently fed, where the nature of the function basically doesn't change on a day-to-day basis. Okay, so in those cases you can use an ROM. So in exam also you might have some questions like this, wherein functions will be given and you will have to make an decoder. You will have to design and implement the function using ROM. Okay, is this
So the connection with the read enable and the data lines are tri-state buffers, right?
Yeah, they're tri-state buffers. Okay.
Any reason why they're used over an AND gate?
Over an NAND? No,
Over an AND gate.
Yeah, you can use an tri-state buffer is also is much easier to implement at the transistor level, right? And it will just so
Okay,
that's why they have used it. Okay. Okay. So now there could be another example of ROM I am going to give here, which is design a combinational circuit using a ROM. It accepts a 3-bit number and generates an output binary number equal to square of the input number. So these are the input numbers, right? So the last digit is going to be it is 7. So 7 square is 49, and for to represent 49 you will require 5 bits, right? So minimum number of output bits will be 5. So this 5 comes from this 49 here. Okay, so this is the decimal numbers and these are the equivalent binary numbers. Okay, so first of all, seeing the table itself, we should not straight away jump to the conclusion that we might require 3 inputs and 5 output ROM, right? If you just see these 2 inputs, if you see A0 and B0, they are exactly the same, right? So you can straight away pass A0 to B0 without using a ROM, and similarly B1, everything is 0, okay, for B1. So you don't have to use B1 also. So we can use only an 4-bit output RAM itself. So if you see, so A0 you are giving straight away B0, and 0 you are giving it to B1. So this is A1, A2, A3. This is how you are got to program B2, B3, B4 and B5, right? So this is going to be the ROM truth table. Is it okay with all of you? Have you understood how to generate a ROM table? That's very, very basic thing. Is it clear? Can anybody prompt yes or no? Yeah. Okay. So I'll upload this PDF also. So you can search in the net 1 or 2 more examples of ROM design. You will get it. So you might want to practice 1 or 2 examples, then that will prepare you well for your exam. So today we have finished off with the ROM programming. In next class we will talk about PLA and PAL. Okay, how they're slightly different kind of programmable logic devices. So we will discuss about that in detail in the next class. Okay, so that's all for today.